Welcome everybody to SQL Friday. This is SQL Friday number 28. Our star of today is Jayakumar, who is connecting from India and about data security in Azure SQL with Azure KeyVault and Always Encrypted. And I really look forward to it. Jayakumar is a correct me if I'm wrong, but I think you're a C# corner MVP. Is that correct,
Yes.
Jaya?
Yeah, correct.
Right. So it's going to be interesting to see more from I guess what we will see is more from a client developer perspective. And then next week on SQL Friday, we will have Uwe Ricken, who will very much talk from a DBA perspective. So it's good to get both points of view on this. Welcome, and just take over the screen share when you're ready, Jaya.
Yeah. Yeah. Hope I will be able to see my screen.
I see the screen. Yes.
Yeah. So thank you, Magnus, for accepting the session. So and giving me a chance to get this delivered to the folks over there. So welcome all. So as today we are going to see how we are going to secure our data which is stored in Azure SQL using the always encrypted concept and Azure Key Vaults. Before we get into the session, so here's my short intro. Like I'm myself, Jayakumar Balasubramaniam, work as a product lead in a company called Hubfly. So I'm a Microsoft certified trainer and a certified developer and G# Corner MVP. So here you can get in touch with me in any of these platforms. So let's get into the session. So what is mean by that? We always encrypted because you know that everything we already saving the data in Azure and they have a lot of compliances already implemented, and probably we have our connection strings established with our secure usernames, passwords. Yeah, everything is all there, but still the data is open over there, right? So whoever have the access, whoever have the proper access to that DB, or if whoever have the proper access to an application who can write a code to connect with the DB, they should be able to get over there. So that still data is insecure over there, right? So maybe there may be some sensitive data like credit card numbers or SSO numbers, or if there is any OTP passwords, anything can be there, right? If you are a database administrator, then you will have an entire access to the database. If you have a bit of knowledge about how to query or how to open up a table, then you should be able to view all the sensitive data. That's again we are losing the security there, right? So that's where this always encrypted concept comes to play a role, and that's we are going to achieve with the help of Azure. And yeah, even though we run our Azure SQLs nowadays, SQLs running in the Azure, still we should be able to do that over there. And the beauty of this is that this is just a concept of always encrypted. There is nothing to deal only with Azure or only with on-prem environment. But still, we are going to look at how we can achieve with the Azure, because we have everything available in the online. So when coming to the encryption, we talk about there are definitely they are going to be involved with a key, right? So we need some key to encrypt the data. So basically here we are going to discuss about two keys. We are going to have a master key and an encryption key. So the encryption keys are used to encrypt the data in a database. So these keys which will be stored in a database in an encrypt form. So that it just keeps the keys in the database, and the master key is the one which gets stored in the external key store. So which is used to encrypt the actual encryption key. So this where plays a role because the master key, this where we segregate our encryption. So whatever the key that you use to encrypt our database, the key will be in some other environment. Even you are an DB administrator or if you're an application administrator, you won't have an easy access to that key. Maybe you could save it either in a Windows certificate store, either in a trusted form, or if you could use the Azure KeyVault, then you could even able to save it over there. And even from Azure KeyVault, it's not that easy to read that. We need to implement some specific protocols and specific ADRs has to be created. Then only you should be able to access it. Even though the key resides in that, then you will not be able to access it directly, right? So there were some access specific issues will be there. So your data is segregated, and your the key that which you use to encrypt the data is already segregated and stored in any of the key store. That's the play of master key, and the encryption key is the one which used to encrypt the data within the database. So the major beauty of this always encryption concept is whatever the thing that you see, it won't be decrypted in the either in the database side or in the client side. The query driver that which we are using, it will decrypt or encrypt the data on the fly by using the specific keys with the specific privileges to access the key. It's going to decrypt. For example, our key will be saved in the Azure Key Vault. Just a minute, yeah. Our key will be saved in the Azure Key Vault. Then the key vault will be accessed via some ADRs. Then only with that help only we should be able to access the data. Will be showing you the when I show you the demo, you should be able to see all these technical terms so that you get some better understanding. Yeah. So when it comes to encryption, so apart from the keys, what we are using, the second thing will be that algorithm. What kind of algorithm that we are going to use to encrypt the data? Again, so there is no specific way that we can define our own algorithm, but still there are two defined algorithms already exist in the SQLs. The first one is randomized and the second one is deterministic. So from the name itself, you should be able to say that it is a random one. So it's a random algorithm, right? So it uses a typical method, so which is less predictable. So whatever the data that is encrypted using this algorithm, the algorithm format is different. So whatever things you do, there won't be any sequential format. It will be in different random algorithms. But there's some problem with that. Since it's defining multiple algorithms, we will not be able to search, or we will not be able to do any of the major SQL operations like search or group or indexing or joining on these encrypted columns. So basically this encryption is done on the column specific one. So for example, if you have a table called username, date of birth, and the email, then if you want to encrypt a column called email, and if it is encrypted using the approach called randomize, then it is not possible for you to search using the email. For example, if you want to use it in the where query, or if you want to use it in any indexing or joining, then that is hard over there. But still, if you are not going to perform any of the operations on that specific column or on the specific data, which may be a sensitive one, then you can definitely use that. And the second one is deterministic. Yeah, deterministic, you see that it's always generates some same format of encrypted value. There will be some specific format which it gets generated. So it will be easy for us to query the table and perform any operations like lookups or joins or grouping on any of the encrypted columns. So these are the two types of algorithms that we are going to use, and these are the two keys that we'll be implementing. The major part is, so the advantage with this is there is no need that we need to encrypt entire database, or we need to decrypt the entire database, because there may be some unsensitive data, like for example, if you are going to just display the user some identity which is auto incremented, then there is no need to encrypt that, right? Also, suppose if you are going to display just age in a column, then there is no need to encrypt that. But Obviously, you may need to encrypt the data part, or if you want to encrypt the personal data like business email or phone numbers or addresses, then you'll be able to encrypt it. So it's not about encrypting the complete tables, but it's only about how you're going to, which columns that you're going to encrypt. It's a column specific one. Then coming to the limitations that as I talk about, so when you do these kind of encryptions, your application should not be used by your database should not be accessed by any of the applications, right? So because we will be the encryption window will be modifying the data, and we will be doing some performing some operations over there. So in that scenarios, if we are doing some operations, maybe suppose if your application is accessing this database, then it will cause an issue that you may won't get any of the proper data. So for example, if you want to implement this encryption algorithm within your production system, then when you move to production system, your application should not be used by anyone else. So better to stop the application which is accessing this database. And yeah, the second one is parameterized execution. It's the only possible way to view the encrypted columns. For example, if you have encrypted any email, or if you have encrypted mobile number, then if you want to apply some var conditions over there using a regular var query, then it is not directly possible to apply directly, because there also it prevents. So you need to it's a completely parameterized one. So it will just verify whether the given data type is matching, then only we will be able to execute it. Then again, we have another great drawback that it is not possible to encrypt all the type of data types. So for example, there may be some data types, but still there are still some standard data types that we should be able to encrypt, but still like some date, varchar, date time like that, we may face some issues. That's the one drawback of this encrypted approach. And yeah, here comes the real-time use cases. For example, assume that you have your application, both which is running on-premise, and you are an application administrator. You have your application running in your on-premise server, and you have your database server which is also readily available and which is running in another server, and you have assigned some database administrator, or you have as a contract employee. Then if your sensitive data like OTPs or any phone numbers, these kind of data is available in the DB, then this administrator should be able to access the data, right? Obviously, he should have the knowledge of accessing the database. This where this sensitive data gets leaked. So what this always encrypted concept can help us is, if you, as we see in the first slide, whatever the encryption that you do, the encryption key we will be saving in the external stores, right? Maybe it can be any of the Windows store, or if a certificate store, or if you want to save it in the Azure KeyVault, you should be able to do it. In that way, suppose if you are using your application, if you're saving it your key in this trusted key store, then this DB administrator don't even need an access to that key. He simply go and access this database server, like maintaining the server, or taking the frequent backup of the data, maybe some optimization he should be able to do. But still, even when we query the data, he won't be able to see any of the data, because it's all completely encrypted, right? Completely encrypted, and the key is stored in a separate key store. This administrator won't even have an access to this key store. Only this application will be able to access the key store via some security concepts. Then it should be able to query this DB and decrypt the data on the fly. Then it will display to the user. That's how it works. And again, if you have both the concepts, like your VM is, as I said, that this always encrypted concept is not restricted to any of the environments, like only for cloud or only for on-prem environment. Because in the second scenario, suppose if you are hosting your Azure, if you are hosting a database server in the cloud, and if you are a cloud administrator, then if you want to again, suppose if you are going for a third service providers, then in that case also your data will be already exposed. They should be have an access, right? So in this case also you should be able to access, because however you have your VM running in your cloud accessing the database, and you have your application separately running, and you can have your encryption key stored in your key store. So this key store will be accessible only to this application, and it won't be accessible from a cloud or from any other database server, because this application is just going to contact the key store which resides within this server, and just going to take the key and pass it over to the DB to encrypt and decrypt the data. And again, coming to completely cloud. So completely cloud in the sense like the scenario that I'm going to show you with, because I have built something like this. You have your DB server available in the cloud, and everything application is also running in the cloud. Here maybe you will be having a same user who can be an admin of both the things. I think in both the things, but still you have everything stored within your Azure KeyVault, which is highly secured. Some demo, so I think that will clear most of the doubts which we are getting. Let me share the screen for the demo.
Yeah, we had one question in the chat about in which key store, where would you store the key? But I answered for you that I think that will be clear after the demo, probably. So.
Yeah, probably. So first I will, key store. Just let me answer the question first. So I think this is the correct one. Yeah. So this is the key store which will be available in a server. This is my local machine. So I have my certificates. I can create it over here. So this is one option that we can use as per the slides that I have shown you over here. In the Windows server, on-premise server, you could be able to use this key store. And you can write your application to read the keys from this key store. And the second option would be like Azure KeyVault. As you know, everything will be in the cloud, right? We can use Azure KeyVaults. So let me show you how we can implement this so that you get some better understanding. So sorry for the trouble. So I have created the tables for your explanation. So but I missed to enter some data. So I think the internet, yeah. Now let's assume that I am a DB administrator, I am doing a demo, and I am going to access the table. So if you look at, I have created everything in the Azure platform, yeah. So here I have created, you can see in the dashboard, like I have created one database server and one database and one Azure Key Vault. So where I'm going to save my encryption key over here. I should have, since I'm the admin, so I should have the enough permission over here, like I'm the owner of this. Now let's go to our database. So here I have created three tables like user, leave type, and attendance. For example, let's have some entry over here. I think my SQL is a bit slow, I guess.
It's always when you do demos, it's going to be twice slow.
Let's put something. So now this is just a non-sensitive data, right? So it's just a leave type, which I no need to worry about. For example, let's have one just for 2 entries. So there is no one going to deal anything with this because this is just a non-sensitive data. Now let's have other table. For example, let's put in my name. Check, check. And let's assume this access code is the OTP of my user login. Suppose if you are saying something like this, why it is slow? Yeah. Okay. Now we have got our So as a DB administrator, suppose if I log in, I should be able to view all these personal data of my application, which I should not expose. So what's the solution for this? That's what we are going to see now. So with the always encrypted column concept. So as I said, this user ID is just a primary key. Maybe this is also sensitive at some cases because the user may delete the data, but still for the example purpose, I'm just going to leave this user ID as it is. Now I want to encrypt the column and I want to secure my sensitive data. So what I'm going to do is just going to log in, and if you look at here, there is an option called encrypt columns. So it's our wish to whether what columns that we need to encrypt. Yeah. So before we start with the encrypt, so which we see in the slide, we need two things, right? Keys and algorithm, encryption algorithm. So first thing is to create a key. Before we go into this, so let's go to the security section, and you can find this always encrypted key section. So where you can create the keys. So first thing is we need to create the master keys. So master keys helps to encrypt the encryption key. So first we need to create the master key. New master key, just right click on that and create a new master key. And name something like SQL Friday key. So here you can choose the store. So someone have asked, right? We have these much options to store the store, like be it a certificate store of current user or even the local machine, then even Azure KeyVault. So here I'm just going to use the Azure KeyBoard, which I have created. So it's just going to ask the pop-up. And if you look at, since Azure, nowadays Microsoft is syncing everything, you get everything synced up. As soon as I logged in, I got all my subscription and it pulls up my Azure keyword. So it is over here, and just click the generate key. Our key got generated. There is no expiration date. If you want to set it, you should be able to set it. Now I'm just going to create.
I think, to be honest, that even if you set an expiration on the key, SQL Server is not going to bother about it. It's still going to be able to use the key. So at least that's how it works with if you use transparent data encryption. It doesn't matter if your certificate has expired, you can still use it.
Okay. Fine, maybe I'm not sure, but still, if it since the expiration is set in the Azure Key Vault, maybe we get. I haven't explored that, but we'll check that.
Yeah, and it's always, I mean, maybe with key management, you should change the key from time to time. So
Okay.
it's a good idea to keep track of it anyway. But I don't think SQL Server is going to be. You're still
Okay.
going to be able to access your data, which is kind of important. So.
Okay. Yeah. So now the second thing is creating the encryption key. This is our second step. So which we need to choose the master key because these encryption keys are helps to protect the data and which will be encrypted against the master key. So I'm just going to create it. Again, it's going to ask me because it has to read the master key from the Azure KeyVault. Okay. Why we are getting this error? So because we have to create a policy and access enough permission to read the key from the key vault. Just let's go to the Azure Key Store. If you look at here, there is a policy section available. So let's choose everything. So here, if you go to the policy section, you have we can create a policy, and if you want to grant in the Azure Key Vault, there is a policy sections available where you can go and create, and if you want to grant any user permission to access the keys, you should be able to grant it. At the same time, if you sorry, let me add this first. Here it is. Access policies. And you can choose from the template key, secret, and the manage. Suppose if you want to grant any encrypt, decrypt permissions. So I think we for the cryptographic purpose, we need these permissions as well. Then you can select the principal to whom you want to assign, be it a user or maybe it can be any of the AD apps as well, right? So because always users not going to access this key. If you are going to integrate this within your application, then it will be then we can create an Azure Active Directory app, which we can use it. I think I have already created. Let me try to open that. I forgot the name of that. Active Directory, where you can create some app registrations and you can use this database secure app. Let me try that. Yeah, database secure app. So now I'm just going to grant the permission to this app. Just add it. Now both this identity, the actual user, I mean myself Jayakumar, I can access the database because I have granted all the permissions. Now also only this application can access. No one else will be able to access the DB, even they are a database administrator. Here, now the error got cleared, right? Because we have granted the permission to encrypt and decrypt the keys. So that's so even I am the administrator of this database, without the proper permission to my key vault, I will not be able to access these keys. Now we have got both the keys. That's how our first use case got covered. Like even the DB administrator, I am not able to access. Now let's go and encrypt this. So now the actual implementation comes into place. So let's click the encrypt columns. Yeah, so this is the actual result. Let's go to next. So here we will be picking up what are the columns that we need to encrypt. Yeah, and here you can choose the key. Since I have created only one encryption key, this drop down is disabled by default. And here you can choose the columns. What are the columns that I'm going to encrypt? So as I said, I'm just going to leave the user ID because I consider that it as a non-sensitive data, but still I want to encrypt all my personal data of my users. So I just selected all these columns, and here is my sorry, here is my algorithm. This is what we see in the slide. We have two types of algorithm, deterministic or randomized. So if we go with determined, then we should be able to perform the SQL operation. So I'm just going with that. And if you want to change the key, you should be able to do it. This is the default one, but still I'm going to use the one which I created. Let's choose the deterministic for everything. Now let's go to next step. I am already using the existing keys because I already created the key. So this step is skipped. Now again, so this is one special setting that we have in SQL. So suppose if you want to encrypt and decrypt the columns, you no need to come to this window. If you want to generate a PowerShell script, then it will also generate it for you. Let's create something at the desktop. Create user column. I want this PowerShell script. These are the columns that I'm going to encrypt. Let's finish it up. Okay, I think it just created the PowerShell script. It's just not implemented it. Where is that column? So here you get PowerShell script. Suppose if you want to decrypt or increment, then you can just simply go and execute this scripts, because instead of going to this Azure window, you can simply use the script. But now I'm going to use the Azure window again, because always this will take time to load the window, then pick the column, then executing it. So that's why we have an option to generate the PowerShell scripts. Now let me go with that same approach again. This time I am going to proceed it. Yeah, so here are good. Next, let's proceed to finish now. So it will take some time based on your data size. And again, the key thing that you want to consider here is, suppose if you have launched your application and it is been in live for more than a year, and now we are going to implement this always security concept, then that encryption may take time, because it needs to encrypt all the data within your tables, right? So also it depends on the data size. The time that it's going to take is all depends on the data size. Now even if you see, I have only two columns, but it's taking some time to encrypt. But this is one-time activity. It won't cause any major drawback or performance issues when you access it or decrypt it from your application. So it's just about implementing and saving all the data while encrypting. It's taking some more it's taking some more time. So okay, so let it encrypt. So in the meantime, so let me explain you the how we can implement it from even from the your .NET applications. So for example, I have my so this is my .NET Core application. So where I have created, just use my entity framework concept. If you look at here, I'm just going to grab the key value from the Azure KeyVault. So I have my key vault. As you see now, I have enabled the permission to my Azure KeyVault, and here I'm just going to pass in my I'm just going to use the Azure KeyVault, and it's going to return me the access token. As you see, we are just going to grant the permission to the Azure AD app, because end of the day, when you're going to implement it in a solution, you need some client app to read the keys from the Azure Key Vaults, right? So it's not going to be an end user. So that's where this AD apps comes to the play, and this will help us to create Azure Key Vault provider. Then the only thing that you're going to pass is, let me zoom in. Just going to pass in the provider, and by default, we have an in the SQL connection in the .NET, we have an option called register column encryption key store providers. So where you should be able to pass in your Azure Key Vault provider. Then automatically while executing the task, so our .NET application will read the key from this key store, and it will decrypt the column from the SQL, and it will return the data for us. Oops, still processing. So let me show you something in the if you look at here, so it's just about passing our client ID and the client secret for the Azure Key Vault. So there is nothing like a username or password. So it's just a client ID and secret, which you have already secured. Why it's taking?
Try running the select query and see if it got encrypted or not.
It should not be. It's not that. Probably let's try to execute the Powershell script that we have got. So it should be done pretty much fast.
And then you need the Azure SQL authentication context.
So it will give us, that shouldn't be a problem. So we just need a SQL Server password. I forgot the password. Let's try. Demo at $123. Yeah, it is done. Thank God. It takes that much. Sometimes it takes time, but for 2 rows, it shouldn't have taken this much time. Maybe my internet also bad. I'm not sure.
I think it might also be the works of Management Studio, not it. It would be much more interesting to see some more information from Management Studio instead of just working and then passed, because it's doing a few steps.
Right. Okay, I have connected using the option. Okay, now if you see, even I got wondered that why I'm seeing the data even after encryption. So this is how it works. So let me disconnect. Let me disconnect the query, and let me connect it again. So now I'm going to encrypt. I have encrypted the column, so I know I have access to the master key. So definitely I am an authorized person to view the data, right? So how we are going to view the data, the encrypted data? It's so much hard to build an application view data, right? So that's where our SQL Management Studio have given an option. Since I'm already doing it for a demo, I enabled that option. That's why I'm viewing it. If you go, when you're connecting to your SQL server, there is an options button over here. In this option, if you enable this one, and connection string setting, I'm not able to zoom it. So connection string setting, encryption setting is enabled. If we have mentioned this, then you'll be able to automatically read the data and it will automatically decrypt it for you. Now I have just disabled it. Let's see how it works now. Something happened to my SQL Studio. It shouldn't take this much time just for the connection.
It's always when you run a demo, everything is slower. But I think it also could have something to do, since you're on a Teams meeting. Teams uses quite a lot of
Being a
resources.
developer, I have these much systems opened in my machine. Being a developer, maybe that's also slowing down my machine, I guess. Oh, I have the query already. I think I should close this.
Yeah, because it's using your old connection.
Let's make sure 1 second. I forgot the table name, else I should have entered. Yeah, table user.
You need to change the database context too.
Yeah, got it finally. So if you look at the my personal data got encrypted. Yet as I said, I just left the user ID for intentionally for the demo purpose, and even the DB administrator, I have all the access even to delete the database, but still I'm not able to view the access code or whatever the personal data. So that's what we tell. The data is always encrypted wherever it is. Only if you have access to the specific key store, you should be able to read it. And so, as I said, suppose if you want to run a query, you will not be able to do it. For example, I want to select, but still I can run a query by targeting my user ID because that's not encrypted, right? I can get it, but still I will not be able to get it. I think I have given Jayakumar. We will get an that is an encrypted column. It has to be parameterized one. That's what we are getting, and also the column is encrypted, so we will not be able to use it. Okay, let's try. This is what I told, that it has to be parameterized one. We cannot directly pass it. So let's declare a variable. So I think it is a varchar of 50. Let me check once again. As it is validating the parameter, we need to give the proper name. So it's a varchar of 100. This will execute now, but still we won't get the result because we don't have access to the key. Yeah, even though this is not executing because we don't have access to the key and we will not be able to perform any actions on these encrypted columns. Okay, now it's time to decrypt and view. So let's create another connection. Let's disconnect, copy these queries, and let me close this. And now, as I said, so you just need to give this always encrypted enabled. I think that's enough. I'm just going to paste my query. Okay, let's see how this works now. Still, I think that the parameter value. Yeah, this one. Columns encryption setting enabled. So I think I have to give this one. And like just for this. The options, I'm just going to put in this code, column encryption setting enabled. Now I'm going to connection. Even in your connection string, you have to mention this, then only your application will be able to read it. Let's open some new query. Yeah. Now I should be able to read it. Now it's just going to ask me to enable the parameterize. That's what I just disabled now. Suppose if you want to enable the parameterize one, you should be able to view it. And again, since I have already logged into my keyword, it hasn't asked me to log in. Yes, I will get a pop-up to log in to this Azure SQL keyword. Now again, so now even though this thing won't work if I give it like this. Even though I got it decrypted now, since I have enabled with the KeyVault permission, and also I have enabled the permission to this user, this won't work. Because it is completely parameterized one, then you need to give it like this. It will return the value. So this again secure your data like with the proper validation. Yeah. So I think that's what I wanted to discuss today. Like now we have, so we should be able to always encrypt our column and keep it anywhere by keeping the store anywhere else, key anywhere else. So maybe now we can, it's time for queries. If we have any queries, we can go with that. So probably this should have answered the key store questions which was asked at the earlier the session.
Yes, I think so. And then, like you said, if you're running everything on premise, then, well, maybe it could still be a good idea to use the Azure KeyVault, because then you have a central key management. You don't have to distribute the certificates and key to the individual application servers, as long as the server application has a token to connect to the Azure KeyVault, then
Right.
you still store it over there. Which I think is a very, I mean, you could use Azure KeyVault or any central key management system, which is probably a much better idea than having to import it to your certificate store on each machine.
Yeah, right. Yeah, exactly. That's just an option. So still, yeah, the one to use it is the best way to deal. So hope this is helpful, I guess, for the folks who have joined to keep the data secure.
Yeah, thank you.
Thank you,
And
everyone.
then there is a lot to think about. You choose the deterministic, and you can always, if you choose the non-deterministic encryption, what that basically means is that with deterministic, then a value is always going to get the same encryption hash, basically. So
Right.
it's going to be encrypted to look the same. But if you want really strong security, and that's going to depend on what your SecOps department will tell you, or how they consider it. If you want stronger encryption, then you need to set non-deterministic encryption. But it's a performance versus security discussion to have, I think, because
Yes.
non-deterministic takes a lot longer to decrypt than when you send in that when you query your data. It's not always that you will get the predicates to run on the actual database. You could run into a situation where your application needs to pull more data to the application server and do the predicates on the application server instead. So it's a few things to consider, but I think with deterministic, it should be just all set to go, and it shouldn't affect performance that much.
Right. Correct.
Cool. So thank you so much for coming.
Yeah. Thank you. Thanks for this opportunity to share the knowledge.
And I think it's an important topic that people should probably study a bit more than they do, because even with, as you say, even if you use Azure SQL database, you have the connection is encrypted, and the actual files, the backups will be encrypted. But if you just have a username and password for the Azure SQL database, then you can read all the data. So it's another layer of security, which is, you can't just trust one layer, because someone could get a hold of your passwords. So thank you so much. I am gonna stop the recording and then do my best to get the the recording edited, and hopefully later tonight or tomorrow it will be uploaded.
Sure. Yeah, thank you.
So for you, Jayakumar, I will mention you in a tweet, and then you will see where the video is. And for the rest of you, just go to sqlfriday.net and click on past sessions. That's where I upload all the recordings. And that goes for the 27 ones before this one. If you're curious what we have done the previous weeks, then just have a look on sqlfriday.net. Thank you, Yaya. I'm going to meetings now. Yay.
Yeah.
To finish
Have a
off
good
the
weekend,
Friday.
y'all. Yeah, bye.
And you. Bye.
Thank you. Bye.